Here we are discussing phase propagation in a string. Earlier we discussed that in a simple harmonic wave, in SHM wave, simple harmonic wave, all the particles in a medium, all the particles in a medium execute SHM. They execute SHM. The execution of SHM, it may be perpendicular to direction of propagation, perpendicular to direction of propagation, or parallel to direction of propagation, parallel to direction of propagation. So this is also same here, perpendicular to direction of propagation. In this case, if it is perpendicular to direction of propagation, you know this is transversal wave. It's a transversal wave. This is longitudinal wave. It's a longitudinal wave. In the medium, all particles which are executing SHM, all particles in SHM, they transfer the energy. So this transfer the energy from one to another, one particle to another. So this energy means due to this energy, wave propagates. Due to this energy, wave propagates. Continuation, how the waves are generated in the string. How the waves are generated in the string. So let us discuss about this. So in generally, first one, this is the vibration of the particle from its mean position is a direction. This is a string I am taking at. Here is a point. The particle can vibrate up and downwards. So if we choose this is the amplitude, here minus a. Initially at t is equals to 0, so its position is like this. So particles vibrate perpendicular to direction. So first one is what? From here we can say particles vibrate perpendicular to the direction of propagation or direction of the string. Direction of string. Now, when this end is just the end is, it's what? Vibrated. Vibrated means what? Generally the wave should be vibrated like. So this I'm showing as next one more diagram. This. So it is pulled up to here, just imagine. This is pulled up to here like this. Okay, so is what? A, this is minus A. When it is pulled upward, all the particles in the string, they all will be directed upwards. So what is the reason? Because all the particles connected to each other. So why they are moving means what? All the particles are connected to each other. So they are connected to each other. These particles will move upward with some velocity, and momentum. Some velocity and momentum. Next one. So when this one reach the top and the string returns back, if the string returns backward direction, okay, say in the case this is in the direction where in which way it is moving, so vibrating. So if this string, if it comes down, so it reaches to this point, it comes down, so this is the position of it. Here, whenever this string, this part is pulled downwards, the particles are directed down and the remaining particles are in the same like initial one, upward direction. If the particle will complete half of the oscillation, if the particle will complete half of the oscillation, so then the position will be like this. So it's what, like we can take it as, this is what, it's a pull downward direction of this motion, and next one here is what, it's in a upward direction. So these will continue in the string, like a half part will act upward direction, half part will act downward direction. So now the particles comes to the downward direction and upward. So this completes a wave. It completes a wave as shown in the figure. So here the particles are upward. It's what it depends on, this end is fixed to the vibrator. Okay, vibrator which is making the oscillation like. So these particles are like, and next one is, it is what, upward direction. This is that the length of this wave is lambda, which is wavelength. Okay, so the wavelength, like this wave train will be continue to complete the wave with a particular direction. So in this wave, just I'm imagining here, the first one is that one wave pulse is here. Just imagine that it is at t is equals to 0. This wave pulse travels from here to here at t is equals to t. So this is from here to here, distance traveled is Vt, distance traveled by the wave pulse from the t is equals to 0 to, so t is equals to t is Vt. So next one, when the wave is propagating in this direction, after a time t, the displacement of curve, is y is equals to f of x minus vt. So next, when it is, the total distance is what, x, and remaining, so that is vt, y is equals to f of x minus vt, when the wave is propagating in forward direction. Forward direction means what? Positive x-axis. If the pulse traveling in backward direction, y is equals to f of x plus vt. So when the pulse is traveling or the curve is traveling in a backward direction. So backward direction is what? Negative x-axis, we can say on this.